The test of a first-rate intelligence is the ability to hold two opposed ideas in the mind at the same time and still retain the ability to function. Francis Scott Fitzgerald.
Appendix 5, Quantum Subjectness.
Allow me now to present for your consideration a possible new approach to interpreting the phenomena of quantum mechanics. Within the paradigm of the Great Graveyard, every existing interpretation in this field of knowledge is simply incompatible with common sense. They sound profoundly illogical, utterly mind-blowing to the average person. Take just the theory of multiple and continuously multiplying parallel universes. It seems all this absurdity arises because scientists interpret the objects of quantum mechanics and particle physics as some kind of strange things, as intricately designed mysterious contraptions, as if they were some kind of mechanisms, while in fact they are dealing with proto-living entities. Let us again note that nuclear physicists, just like the astrophysicists we mentioned earlier, readily use terms like birth, lifetime, and death in reference to elementary particles. Why? Because it's the most intuitive and easily grasped metaphor. At some point, a particle appears, is born, exists for a while, lives, and then suddenly disappears or decays, dies. But let's return to quantum mechanics and first clarify, what is a quantum? The term quantum comes from the Latin quantum, how much. In the interpretation of the Great Graveyard paradigm, a quantum is an indivisible portion of some physical quantity. For example, people speak of a quantum of light, quantum of energy, or quantum of a field. Physicists also hypothesize the existence of quanta of gravity and quanta of time. Roughly speaking, if the term quantum is used, it means that it simply can't be any smaller. Physicists also use the term quantization, when a measurable physical quantity can only take certain discrete values. And here, I'd like to remind the reader of the entire chapter called Discreteness, which I, somewhat mysteriously, placed at the beginning of part 2 of this book. There, we spoke of how discreteness is one of the properties of life, how any subjective entity perceives reality in the form of discrete, informational events. At that time, this conclusion was left hanging in the air, but now, when we understand that absolutely all matter is subjective, we can begin to explain the nature of quantization. Elementary particles, being proto-living entities, just like all living beings, possess threshold and differential sensitivity. We smell a burning pie only when the number of aromatic molecules in the air, the objective text, exceeds a certain threshold, and only then do we perceive the informational event. The pie is starting to burn. Likewise, any elementary particle picks up texts from other elementary particles only when the stimulus exceeds a certain threshold of sensitivity. And let us not forget that all detectors and recorders used by physicists in their experiments are themselves subjective entities, in essence, still the same proto-living observers with their own threshold and differential sensitivity. That's why they can only register discrete values of measurable quantities. Now that I've mentioned the observer, let's dive into the so-called observer paradox in quantum mechanics, the conclusion that mere observation of a phenomenon inevitably alters its outcome. To do that, we must first climb onto the widely disliked platform of philosophy, recall that reality is dual, meaning it is represented by two mutually structuring realms, the realm of energy and the realm of information. We've previously concluded that life organizes energy through information and organizes information through energy. That is, thanks to information, the model of the universe, any subjective entity manages to organize its internal energy, its body. And thanks to organized internal energy, its body, a subjective entity can gather and organize information. Remember that? Keeping this in mind, we now need to expand our understanding of the states of matter before and after the event of death, as well as before and after the event of birth. Recall, we discussed these events in the chapter Death and the Emergence of Life. I solemnly promise, right after this, we'll return to the friendly jungle of quantum mechanics. So let us reflect on the event of death in terms of what was and what is now.
What was when a creature or proto-living entity was still alive?
Answer. This subjective entity existed both in the objective realm of energy, body, and in the subjective realm of information, consciousness.
What is now when the subjective entity has died?
Answer. Upon death, it, more precisely, its body, remains only in the objective realm of energy and vanishes from the subjective realm of information. It loses its subjectness. As a result, the previously organized body energy ceases to be organized, becomes ownerless, and in full accordance with the second law of thermodynamics, begins to degrade immediately. Conclusion.
Everything no longer alive exists only in the realm of energy.
Now let's try to understand the event of birth using the same what was and what is now format.
What was before, say, the fertilization of the egg cell belonging to our infamously overused Missy?
Answer. In the realm of information, there existed a model of the universe for the cellular society of a dog. And of course, in the realm of energy, there was some nearby reserve of unorganized energy necessary to nourish the body for a while after birth.
What is now after the egg cell has been fertilized?
Answer. Upon acquiring subjectness, it info-cloned, so to speak, an instruction manual for assembly and calibration of the organism, loaded the instinct program, and organized in the form of its body, that very nearby, ownerless energy, that is, it appeared in the realm of energy. Conclusion.
Everything not yet alive exists only in the realm of information.
Let's sum up everything above.
Every element of matter, before the event of the birth of life, exists only as organized, yet ownerless information, a model of the universe. After the event of birth, the element of matter becomes a subjective entity. That is, it now exists also in the realm of energy. After the event of death, the element of matter exits the realm of information and continues to exist only in the realm of energy as ownerless, degrading energy.
I hope that makes sense. And now, as promised, with a sigh of relief, we return from the murky heights of philosophy to the hospitable hell of quantum mechanics. Applying our philosophy to the quantum world, we conclude,
every elementary particle, being a proto-living entity, can exist only simultaneously in both equal status realities, the realm of energy and the realm of information. If a particle is not present in one of these realms, then it is either not yet a particle or no longer a particle.
So far, so clear. But let's clarify, what is this ownerless, unorganized energy in the context of the quantum world? It seems to me that in the quantum world, this unorganized energy must be a wave.
The birth of an elementary particle, the event of the birth of life, occurs at the moment when a wave receives subjectness from some proto-living entity. In other words, when the wave reacts with something.
If this is the case, then within our paradigm of the great life, we can finally offer a coherent explanation for the so-called observer effect, where the mere observation of a phenomenon inevitably alters the phenomenon itself. In quantum mechanics, this effect appears in the classical double-slit experiment. The experiment has two parts. In the first part, a barrier with two narrow slits is bombarded with electrons. Over time, a classic interference pattern appears on the detection screen behind the slits, suggesting the electron is a wave. In the second part, detectors, i.e. observers, are placed near the slits to track which slit each electron passes through. Now the screen behind the slits shows not an interference pattern, but two simple vertical bands suggesting the electron is a particle. To explain this observer paradox, physicists had to invent the monstrously absurd multiverse theory. According to it, the electron passes through both slits at once, but in different parallel universes. When observing the slits, the so-called observer splitting occurs. In one universe, the particle goes through the left slit, in another, the right. But in our paradigm of the great life, there is a much simpler explanation for this paradox. First of all, the electron projector emits not full-fledged particles electrons, but only their not yet alive energy components, waves. In the first part of the experiment, the wave calmly passes through both slits, interferes, and reaches the screen surface. There, one of the proto-living entities, one of the atoms, of the screen surface shares its subjectness with the wave, turning the wave into a full-fledged particle and thereby organizing under its body the full energy of the wave. That is the very event of birth, in quantum mechanics terms, collapse of the wave function, occurring right on the screen surface. And this newborn particle leaves its mark on the screen. In the second part of the experiment, the wave receives subjectness earlier upon approaching the slit from a proto-living entity, one of the atoms of the detector material. From that moment, the wave becomes a fully fledged proto-living entity and behaves accordingly, like a particle.
A wave is an elementary particle that has not yet been born.
And it also seems that
electromagnetic waves are simply texts exchanged between atoms.
Here's a little fairy tale from the life of electrons to illustrate. Long ago, on some distant star, a little electron shifted from one energy orbit to another, and to notify the universe of this pivotal life moment, it emitted a wave, in other words, a text. This wave traveled across space for billions of years until it finally reached your eye. And then, magic. One of your retina's sensitive cells shared its subjectness with the wave, and it transformed into a real photon. For billions of years, no subjective entity in the universe cared about the state change of that tiny electron on a distant star, until your eye came along and graciously completed that overdue informational transaction. And, while we're at it, one more important general insight. Within the paradigm of the Great Graveyard, the science of the non-living, physics, assumes that the nature of reality is probabilistic. But from the perspective of our paradigm of the great life, changes in the state of an elementary particle should not be interpreted as random probabilistic events, but as manifestations of a kind of equivalent of free will. Figuratively speaking, the particle just felt like it, and so it changed its state. With this understanding, randomness vanishes completely from our concept of reality. Any manifestation of chaos in the realm of energy is simply the result of misaligned actions of countless, independent subjective entities across various levels in the hierarchy of life.
The nature of reality is not probabilistic. Reality changes through the free will of a vast ensemble of diverse subjective entities operating on various levels of the hierarchy of life.
Summary.
Everything not yet alive exists only in the realm of information. Everything no longer alive exists only in the realm of energy. Every elementary particle, being a proto-living entity, can exist only simultaneously in both equal status realities, the realm of energy and the realm of information. If a particle is not present in one of these realms, then it is either not yet a particle or no longer a particle. A wave is an elementary particle that has not yet been born. The birth of an elementary particle, the event of birth of life, occurs at the moment when a wave receives subjectness from a proto-living entity, namely, when the wave reacts with something. Electromagnetic waves are the texts atoms exchange. The nature of reality is not probabilistic. Reality changes through the free will of a vast ensemble of diverse subjective entities operating on various levels of the hierarchy of life.